Herzlich willkommen beim Trending Topics Podcast. Mein Name ist Shemsa Salioski und heute spreche ich mit Ramin Hasani von der Bold Community. Ramin Hasani ist KI-Wissenschaftler am Computer Science and Artificial Intelligence Lab des MIT. Seine Doktorarbeit und seine fortlaufende Forschung zum Thema Liquid Neural Networks wurden international mit zahlreichen Nominierungen und Auszeichnungen anerkannt. Und über die sogenannten Liquid Neural Networks, die Benefits, aber auch die Gefahren bezogen auf KI, reden wir heute mit ihm. Now let's switch to English. Ramin, thank you so much for being on our podcast. Let's start with the first question.
Yes, let's do it.
What first drew you to science and technology? And were you that one kid that was building a robot while other children were eating sand in the park?
Yeah, I was always fond of mathematics and physics. So I was like into really understanding like how things work. And it was like the easiest subjects for me, like at school. And then afterwards, I chose to start my career in electrical engineering, where I get hands on with mathematics and physics for developing real world systems and real time systems like circuits and chips and robots, and then getting into competitions and being successful at those. And those are like really like rewarding kind of experiences where we could make things happen, and then they make a big impact. For example, one of the things I did was like a rescue robot that could go into like different places and be effective, like when something happens, like a natural disaster or something, then you can send your robots to really like figure out like.
When was this?
This is like when I was I think 16 years old, so I was like very very young. So this is
All right.
probably like sometime in 2003 maybe,
Mm-hmm.
or 2004, something like that. So a long time ago.
So you were that one kid that was building a robot while others were eating sand in the park.
Correct. Yes. So I've been designing robots since then, and then going up like after my bachelor's degree, I started in as an electronic engineer. So I was getting into like designing now chips like at a nanoscale, and micro scale basically. And then these are kind of control units that can be used as in a car, in a robot, in a any appliances or anything, something that does something smart in the world of electronics. And then so I focused on that, and then I was in Italy, Politecnico di Milano, where I was doing my master thesis in 2014. On my master thesis, there was this professor. He told me that, hey, like we are working on an experimental project. We want to bring neural networks of brain inspired neural networks on chip. And we want to design the next generation of chips. So if you think about like chips and controllers that you have like as an electronic system in your phone or any kind of devices, they are logical systems. Okay, they follow some logical rules, and then as a result of those logical rules, they can perform really well on certain kind of applications of logics and everything. Then there is this new category of things which are continuous and analog. Like the world can be actually modeled into waves. Like the world is like, and waves are analog kind of processes. So you want to interact with the world from the analog perspective, and your brain is an analog machine, so it doesn't do zeros and ones. Your brain is basically doing analog computation a lot. And then as a result, one of the properties of analog computation is the fact that they're extremely energy efficient. You don't need to spend massive amount of energy. Your brain is powered by a 20 to 50 watt kind of energy kind of source, which is unbelievable given the size of your things that you want to do. So ideally, we want to take those kind of insights from the brains and build something on chip which is as efficient as those kind of as the mechanisms in the brain. And then this professor was telling me this stuff, and it was so fascinating for me to get into, like what an opportunity this is, and I really want to take the risk. Like we were all like new to the ideas and to do this. And then we did that in 2014. We showed that in the brains and in biological kind of nervous systems, you have a lot of noise. Okay, so you have a lot of noise. So, and the brain apparently is using that noise as a resource for computations. Okay, So what we tried to do, we wanted to see what's the effect of, can we create a noisy circuit that is actually more efficient than a logical deterministic system. Okay. And then that was basically the goal. And then we managed to do that. We showed that noise is actually a resource for computations. That was my thesis in 2014-15. There I got away from the fact that, all right, so we are designing chips and, like electronics of things, but then I got more and more into the artificial intelligence and the intelligence aspect of things, the software, the algorithms, the things that enable those intelligent behavior. I got so much into those kind of things. And then as a result of that, I found this PhD position in Vienna University of Technology with Professor Radu Gurusu, and he wanted to look into the brains of small animals, and then from those small animals, like he wanted to look into brain of C. elegans, this little worm, and then from there, we take things to really like design new algorithms from there. And this was all software, so I got a little bit deviated from the hardware world into the software world and intelligent aspects of things. My interests, like the career path, and I got lucky to get to know Professor Grusu and the team at TU Vienna. Yeah, so things got started and I became
An AI scientist.
AI scientist. Yes.
Which is perfect because it leads me to my next question. I mean, it's 2023 and AI is everywhere, and especially ChatGPT. And my question is, did this development actually surprise you in any way? Because you were already, where you were working at right now, or was it not a surprise at all?
Yeah, if you're talking about the generative AI kind of movement and the recent kind of development, it was pretty impressive. So, but I have been again lucky, one of those lucky people that had access to these systems like way before, and I've designed these kind of systems way before myself, and so I knew the path that it's going to be there, but the execution that, for example, the OpenAI guys have done is really admirable. I was fascinated by the engineering that went behind bringing this technology at scale in the hand of people. That was like the part that is like super valuable. It was an exciting time. It was a great time to be alive.
I mean, I think that's the craziest part about everything. I mean, students at school are using artificial intelligence. It's insane.
It's pretty fascinating how this movement started and got in the hand of everybody, which is amazing.
Now I'd like to dive more into one of your research focuses, if that's all right. Liquid neural networks. I hope I'm pronouncing it right. Well, in a recent TED talk, you talked about liquid neural networks. Could you please explain what it means for people who are not? I mean, it would be the best for people who are not involved in this at all. That means as easy as possible. And also, my question would be, how can it contribute to the advancement of AI?
So if you look at the artificial intelligence systems, the definitions have shifted so much from the brains. So we started in 1956. At that time, 1956, everybody was talking about, oh yeah, so let's mimic the brain, the computational mechanisms that happens in brains, and then make algorithms out of them, and then this became the neural network movement. Okay, so everything started from there. So but then computer science is all about designing efficient and fast algorithms. Okay, that's what it is. So we started deviating so much from the source, which is the brains, and the operations and the artificial intelligence systems that we see today. They're very kind of different than the kind of operations that happens in the brain. It is true that originally we said neurons and synapses as points of kind of communications. Neurons are elements of computation, like nerve cells that exist in your brain. Synapses are the places where two neurons and nodes are communicating with each other. So it's basically the junctions. The information flow happens at synapses. Okay, so then these functionalities got so much abstracted away. They became so simplistic. For example, we are modeling, for example, information that flows from one node or a neuron from the to the other neuron in an artificial neural network. with a scalar weight. Scalar weight means you have a number. You say that, okay, the strength of this synapse or communication is 5, is 10, is 10.5. Like we associate a number to that kind of communication. But that's not actually what happens in the brains. In the brains, the information flow between two nodes are really like strong. So there are so many different aspects. It's very complex. It's a very, very complex process. Why didn't we encode those kind of processes into artificial neural networks? The reason being, if you encode those kind of complexity, as you make your systems and algorithms more complex, it is much harder to interact with, it is much harder to actually build these systems on hardware. So at the time, we didn't have the hardware to build these kind of systems on top of. That's why we went towards the simplicity. And now we see that even from those simple algorithms, which came the transformer technology, which is the building block of all the our artificial and generative AI kind of large language models and everything are built by these transformers. And then there is like on the computer vision side, we have like some other operations like convolutions and like you have like many different architectures that came out of this simplistic version of mimicking the brains. Okay, so they're very, very simplistic. As a result of that simplicity, we managed to scale these systems very, very large, and that became like our today's artificial neural networks. Now, there are fundamental challenges with these technologies, right? These systems are not, they hallucinate. They're black boxes. We cannot really explain the behavior of these systems, and many more kind of socio-technical challenges associated to this kind of artificial intelligence, the way we create artificial intelligence. My research question during my PhD and then postdoc between TU Vienna and MIT was, can we do better? Can we go back to the source, which are the brains, and then take inspirations from the brains properly this time? Because now the hardware is good. Now we have substrates that we can actually run these systems. Now, what I did, I started looking into brains. I started how information propagates between two nodes in the system. Like, let's say, a neuron that is sending information to the other one. Now, how should I model the behavior of this system so that I'm not that simplistic and I'm not too complicated? I'm just somewhere in the middle, that I capture a lot more of the properties of nervous systems. And now let's build an artificial intelligence system around that kind of topic. So I bring in these complexities from neuronal synapse interactions in the brain of little worm. We started looking at the brain of the worm because in the
Short question, when was this?
this is 2015, 16, and 17. So the start of the process was actually then, and then
Years ago then.
yes, it is basically, this was the start of my PhD program. Okay, so I started working actually on this topic, and then so through years, like we managed to get the whole infrastructure of how these things work, and then the right mathematical formulation that can be the source and foundation of new artificial intelligence systems that are more brain inspired. And what would that brain inspiration give us? It gives us a lot more capacity to learn with small elements, massive amount of things. Okay, it gives us so much in respect to explainability. We can explain these systems if you build kind of systems, and we call them liquid neural networks, because as a result of these systems, you can have the potential to be flexible even after training. So if you think about your brains, the brain is not a rigid system. So after training, it is basically still can adapt itself. So you need to have mechanisms that are adaptable, right? So the adaptability basically creates the word liquid, and this adaptability is a direct result of how brains actually interact in nervous systems.
But how would this then work, like as a real world application?
Great question. So one of the things, like, we started focusing on autonomy applications and real world applications. For example, let's say we wanted to do autonomous driving. We showed that in the space of autonomous driving, you can manage to drive a car with 19 nodes, 19 neurons. You can autonomously drive a car with 19 nodes. That's fascinating. So that's because the current, at the time in 2020, actually, when we started like working on this project, we artificial neural network systems, they could manage to do that with millions of neurons or millions of elements. We showed that you can actually stay as small as 19 nodes to perform the same task, which was one of the fundamental reasons why this technology is very helpful. And the fact that each node of our system is much more elaborated and it's more complex, it enables us to have like a smaller system, but very, very powerful, you know. And then we showed after that that with 30 neurons, you can fly drones autonomously. That's like insane, you know, like compared to, and this, the results of these papers are published in Nature Machine Intelligence paper, you know, like in Nature magazines, and in Science Robotics magazine. They were in the cover of the magazine in both cases. The reason being like the technological advancement is massive, you know, because now you can have a small system that you can understand it, because if I have 19 nodes, I can exactly pinpoint and say that what is the function of every single element in my system, right? That's massive, and that has like amazing implications. We can improve the trustworthiness of our systems. We can ensure safety of these systems. We can do a lot more.
My next question kind of relates to that. I mean, do you know companies that are already using it? I mean, is it a thing already, or do we still need time in order for it to be actually used by people out of the science bubble? Let me put it that way.
Absolutely, absolutely. We have been developing this technology together with companies. Okay, so we had the sponsors at MIT at the time. So we've been working with Toyota, we've been working with Boeing, we've been working with U.S. Air Force, and these are basically companies that the kind of the ultimate goal of this research was to enable kind of explainable autonomy for these people, right? So to provide like kind of the service, and it is actually going in a very, very promising direction, and they are all like kind of at the stage where they're like kind of productionalized kind of liquid neural networks so that they can be used at the product level as well. The other thing is that liquid neural networks are universal computers. That means they can be applied to any kind of data. That means, let's say in the medical field, okay. So I mean, the use cases that are shiny, like autonomous driving of cars and stuff. These are the things that the media actually like goes around and it becomes like big. But the things that we don't talk about are, for example, liquid neural networks are now state of the art on modeling time series data. Time series data could be financial evolution of time, like financial time series. It could be medical time series. It could be user data of a website that you're following. You want to see how. So everything that evolves in time is time series. Okay. And then it could be like recommendation systems, right? Like if you have like Amazon, or you, and if you're Amazon and you want to recommend the next ads or something, what you want to do, you have a behavioral kind of model of your clients, right? And then based on that behavior so that behavior actually is an evolution in time, right? So that's why like liquid neural networks are really good at processing any kind of real world process that has some kind of temporal element to it, and time element to it, right? So you can use liquid neural networks for finding oil and gas kind of spots. You can use liquid neural networks to predict markets for you, and assess risk of markets for you. So you can use liquid neural networks ubiquitously around like all the application areas that involves time series data. Okay. And we see like more and more exponential kind of growth in the use of liquid neural networks in all applications, like simulation of chemical material for designing new material, simulation like finding out predictive kind of mechanisms from let's say vital signals from heart, from your respiratory rate, and from your SpO2, like oxygen levels. So you can actually get those time series and then do a prediction of what is the health status of your system. And you can do that with massively small neural networks. You can do that very efficiently. You can do that in an explainable fashion because these are decision critical applications, right? Like in the medical field and also in the financial field and the business world, you can imagine like you want to understand why your system is recommending like a, let's say like a shorting or selling or buying a kind of position in the market. So you want to have like those things. So there is a massive amount of kind of exponential growth in the productionization of liquid neural networks, and yeah.
Mhm. Well, now I would like to move to questions that are obviously related to AI, but they're more related to security matters. Let's put it that way. Well, your educational background includes degrees from different universities that are all over the world. And my question is, how have these international experiences influenced your perspective on AI research and also its global impact? And also, do you think that there are cultural differences when it comes to the approach to AI? Maybe comparing the US and Europe.
Well, yeah. So when I started my education, so I've been, I did my bachelor's back in Iran, and then after that, I did a master's degree in Politecnico di Milano in Italy, and then my PhD was shared between TÜV Vienna in Austria and in at MIT, and then after that, I stayed at MIT. So I have actually a broad spectrum of those kind of.
You do. It's impressive.
And I can say that on different aspects of things, there is a strengths everywhere, and people approach the people like in the academic atmosphere and universities, they want to stay powerful in that thing that they have been powerful. For example, like in Vienna, logic is like something like is extremely powerful. And we are like one of the like really top notch kind of maybe even top 10 in the world, in terms of like standing in logics, and then obviously like in an AI scene, MIT and the US like is like way ahead in terms of like where what we are doing and advancing the technology and looking out for the future of AI. And because we had a lot of head start, there has been like some risky research that got funded, and then these research ideas like visionary, like the very moonshot ideas, they got funded, and then they kind of became this new growth of technology in the AI kind of aspect. Theoretical stuff like in from Europe is very good. Like theoretical research is amazing, especially like Politecnico di Milano and also like a lot of institutions in Europe. They have like those theoretical advances because there's also like an imbalance of capital going into academia, and interaction of industry with academia, especially in this realm of AI, has been like very imbalanced. Like for example, we had like amazing like in the US is like most of the fund, like a lot of funds actually goes into this kind of direction, and that hasn't been the case in Europe, and even the scale was not comparable. And we have to acknowledge the fact that AI technology is a capital intensive technology. So you really have to invest if you want to make progress, and if you want to become leading a main player. You need to spend money. That's like one of the inevitable things about being in this space. Yeah, I would say on the theory side, Europe has a lot of things to say. Like we have so many key findings coming out of Europe, but then does it make it to the leaderboard in the finance kind of situation, and building capital and building kind of businesses, useful businesses in Europe? No, it doesn't. So those kind of things are getting used by like other kind of countries like China and US, for example, in this case.
Mhm. My next question is, I mean, also related to that, but more about something that people are highly discussing at the moment, and that's security threats due to AI. And I wondered, what are your thoughts on that? I mean, even the UN Secretary General many times called it a threat.
Yeah, so I think there's a fundamentally wrong thing about that. So I don't see AI as a threat. I see the risk, and risk has different levels, right? So you want to quantify the risk of things that you're talking about, and governments and legal, like legislative kind of entities, they have to communicate a lot with AI experts themselves. You know, That communication is key, because when we understand these systems, we design these systems, and we understand the risk of them, we can tell you, we can quantify like what kind of risk are associated with these kind of technologies. And I think as a result of that, I can say that there is no risk, that the benefits of AI are massive, and there's no reason to be afraid of artificial intelligence for no reason. Why? Because in AI, we work on safety and confidence, and like putting like confidence into our system, evaluating with metrics, with quantifiable metrics, what is actually the risk associated to a model. So scientists already know the associated risk, and we can quantify that kind of risk, right? So once you have those kind of metrics, there's no reason to be fearful about something. You can definitely say how this system is going to behave in different scenarios. And for decision critical applications, like fundamental technologies like liquid neural networks that we develop, for example, that could be like one of those solutions there. Why? Because there you understand the system fully. It's coming from a black box to a white box now, so you understand everything of it. So if the design of AI system is moving towards more explainable, more aligned, more kind of safer, these are the things that are definitely is happening in the science community with a massive exponential kind of growth as well. A lot of funding is going into that direction, which is a positive side. And I think governments has to spend time in that and energy in that. Then the AI doomerism has some marketing attitude to it, and people just want to put themselves on a scene or something, and that is absolutely not true. And you don't want to jump on that board, because the field is like really really advanced, and the experts already know what they're doing. It is something that is under control. That said, the future implications of a superpower kind of thing that we are going to build in a couple of years, that is something to be aware of, and we are aware of it, and we are putting quantifiable measures of risk around those even super intelligent systems. It has to be like kind of discussed in a way that interdisciplinary people come together and discuss about these things, and it should not be only around like governments and legislators like sitting together and decide about AI. So it has to be interactive with a lot of disciplines, not only AI scientists, but also mathematicians, physicists, neuroscientists, like people from many disciplines, biology, like, and the application sector and the financial sector. So everybody has to come together to really find out like what are our borderline things, and design kind of regulations around AI. I'm not against like regulations against AI. Like regulations are good, there has to be some sort of regulations, but the fear mongering is something that you should not do, and you should not be on that. So AI is having massive amount of benefit, and it's changing our lives for the better.
Side question, because you said regulations. I mean, there are also so many discussions on if students should use ChatGPT for their essays or studying, etc. I mean, what are your thoughts on that working for a university?
Yeah, so this is basically directly corresponds to every time a new technology came in. Like, do students have to use calculators at school or not? Do students have to use a software that can help them do stuff or not? So it is inevitable that this technology, it is going to be in the hand of students if you want it or not. So the technology is actually going to be available. What has to be changed, and the right question to ask here is, what do the education sector have to do to change their kind of agenda so that we can build like better curriculums around these topics, so that it actually kind of facilitates the coexistence of this amazing technology with the students, because this is absolutely essential, because our power as a nation is in the hand of our kids that are like have infinite amount of energies, right? Like these people, like we need to educate them, and we need to faster make them to. For us, it's like we have limited time. We are on the growth to we're on a trajectory to grow as a species, and to understand the world. We have no idea how the universe works. Somebody has, like, we really have to discover that, and without the help of AI is impossible. So what science is all about is to really understand the world around us, right? And then so using of this technology is definitely something that we have to put it in place, and education sector have to really like catch up on the speed and become like a lot faster than adapting their agendas to those kind of use of those tools, because one way or another these things are going to be all around the world, and everybody is going to be using them, and you cannot just block access to them. So you block one line, another line is going to pop up. It is not going to be something that you can just block it forever. Yes.
Totally agree. All right, let's move to the next block. Well, since we are currently speaking within the context of the Bold community, of course, I also have a few questions on that. The first one would be, what made you join the Bold community?
Absolutely. So people, power of people. So I think the first motivation for me is people that I have been having the opportunity to get to know through the Bold community, like before, like in different kind of backgrounds, like before even the Bold community became the Bold community. And I believe in those people, and I believe that this kind of, as I said before, it is super useful to bring people from different disciplines together in order to make large decisions and bold decisions. So it is absolutely the right way of organizing like a community, and really having kind of actionable items coming out of kind of on conferences and conferences that coming out of our like the community itself. And I think it would get enabled by having an agenda on how can we document, how can we take actions on the conversations that happens during these kind of conferences, because you're bringing key people in the industry that have power and that have sayings about like things around us. And I think it is an absolutely essential move, and it's a genius move to have this community. So that's why I decided to join, and I would love to contribute by providing my own ideas in the fields that I'm an expert with, and also learn from everybody else that are successful kind of people in their own agendas and fields.
Also, I mean, it's a quite young community. Are there any corporations that you have already established?
Yes, so we have been like through the Bolt community, there was some interest from like financial people. So I'm starting a company myself called Liquid AI. It's basically working on the delivering liquid AI technologies to customers. So we are operating right now in the stealth mode, and then soon we're going to come out. Like we have a very very good amount of funding, and successful things like happen to us. And then the cool thing is that we want to come out as a new foundation model startup, where we provide like a new base for generative AI and for a specialized AI. Okay, so and that base is basically liquid neural networks. Because of the success of liquid neural networks as a universal kind of tool that you can apply to many kind of disciplines, so we thought that this would be nice to actually scale it from those academic ideas to the industry and really deliver something that can address those socio-technical challenges that we mentioned before on the artificial intelligence by from foundations, from first principles. And that is what liquid AI is about. We're going to talk to businesses around this thing where we can be helpful, and the Bold community, of course, like it is going to be extremely beneficial in that. I've been talking to some large banks there, and I will be talking to the like Austrian large companies like OMV and many more, like partners of Vico.
Coming back to the term bold. Now I have a very corny question. Can you recall a moment in your career or also in your life? You can pick that, where you had to be bold.
I feel like I have been driven in my life by becoming like that, like the better version of yourself all the time, like being on the top, like being like successful, like really like having that sense of fulfillment in the things that I'm doing. So I feel like that is itself is constantly being bold, so and constantly having this necessity to being like a bold person, because for yourself, not for other people, for any other purpose. It's just that drive that you have, that passion that you have for doing something and having this consistency and determination. It is a bold thing, I would say, and it's a bold character that you would want to have if you want to be successful at something, I never left something half done. So I've been always like, if I started something, I brought it to the toppest level that is possible. And that is a hard process. That is super hard. You have to put your effort, and you really have to be concentrated on doing that thing. And I think that is something that I could say, yes, I have been always had the necessity to be a bold person, and take bold actions, and yeah, so I would say that's basically the case. I can give you even particular examples. There's a mathematical equation that doesn't have a solution since 1907. This equation describes the behavior between neurons interacting with each other. Okay, there's an equation and we don't have a solution to it. Yeah, so I started working on that equation, and I went into a place of like I had like 2 pages of equations that I had to look at, and then I didn't know what I'm actually doing there. But then like I was like thinking, all right, so let me just take this assumption, and let me take that assumption, let me do that, and then eventually, like, I just continued. I said, okay, let me just continue, like doing that thing. Then I finished it. It was 11 p.m. Actually, I was at MIT at that time. It was 11 p.m. I was still in the lab, and I was working on this solution. And then I realized that, oh wow, it actually turned out to a super nice formulation. It was like, that can't be true. I'm just telling myself. I solved that equation, and then I started simulating that, because you have to verify. As I wasn't believing, this was like 11 p.m. at MIT. And in the night. So I was like, I started like simulating the system, and then I saw that the original equation and the solution, they match exactly. And then so that became a nature machine intelligence paper, and I'm very proud of it. And I hope this at some point people would realize the value of this solution, because this would enable massive simulations of brains. Because when we want to understand brains, we do simulations. We make replicas of brains, and then we do simulations. Now, can we do brain scale like at billions and trillions kind of number of neuron simulations? No, today with the current technology, we cannot. With the solution that I actually invented, you can do that. Now I enable simulations of brains at a scale that would never been possible before. So that's the implication of that equation, because it basically describes how the brain works at the foundational kind of level, like how neurons exchange information with each other. That was the equation that I solved. Hopefully at some point some people are going to catch up and work on extensions of the idea. But the thing is that solving that open question from 1907 itself was a dramatically huge moment for myself.
Oh, I can't believe that. It's insane that you're just telling me that, like, oh, by the way, you know what I solved?
Yes. And yeah, so I think these are kind of the things that like moments that I feel like, if I wasn't persistent, if I wasn't determined, if I wasn't like really focused, and really like just not having this fear of failure, and even not being afraid of failure for a second. Failure is part of it. Experience is experience. And yeah, so I think those are the character traits that I followed, and I think it really helped me to get there. Otherwise, and I think these are bold.
Mhm. Now let's come to the final question. Is there anything you would like to tell younger people that are interested in a similar career?
So, what I would say is that you have to first explore. Don't be afraid of exploring different options, different things in your life, because first you have to do a large search into what is it that you're super interested in. What is it that you want to do and makes you happy? Passion is actually overrated, I would say. So passion is very overrated. So if you think about passion, it's like defining and spending time to defining passion. That's, I would say, it's a little bit overrated. So what you have to focus on more is like, how can I live my life in a way that I'm like happy, and at the same time I'm actually contributing something to the world. And that, so happiness and having a good contribution, that requires you at a young age to do many things at the same time. You have to explore first. But then once you figure out like there is something that is like has the potential to be interesting for you, you need to go deep as possible, in that topic. Then become an expert in that topic. That's like another thing. And at the same time, having a continual learning and having an overlook of where the world is going, what are the other fields. Don't be ignorant of these things. So don't have like so much bias about the things that you're doing. It's true that you are working on that thing, but there's like a lot of other interesting thing happens in the world, and this is not like the only thing that matters. So you have to have like this open kind of approach all the time, while having an expertise and developing an expertise for yourself, and then don't really like get too much kind of distracted by the passion kind of conversation. And I would say like the approach would be like just do it, like the Nike, and it is basically like execution is extremely important, even if you're like doing something small for 3 months and an internship somewhere, or exploring some opportunity. That has to be something that you devote your time and execute and provide like your best self to actually do that thing. And then only after the execution time you realize like how valuable these things has been, and you can assess that process, and you can say that, okay, do I like it or not? Because when you, in the process of doing things when you're young, you still like, you might one day you hate what you're doing, one day you might love what you're doing, but then I would say like process of completion of a process, like of a job or an experience, that moment can give you the idea, like that's the time to assess, while you're doing it, just do it and have fun. That's what you have to have. Yeah, so that would be my 2 cents.
So you answered the final question. Thank you so, so much for being on the podcast. Thank you so, so much for your answers.
It was a pleasure to be with you, and I'm looking forward to the conference.
Alright. So, und das war's auch schon mit der heutigen Folge. Danke fürs Zuhören und bis zum nächsten Mal.